Hello everyone, and on this lesson we are going to look at the multitask model, and also you're going to be touch a little bit on the transfer learning, and you're going to see how you can leverage from pre-trained models from the community and use in our own models. Okay, so this way you don't have to go through the whole training phase and spend a lot of time. Instead, you can use a pre-training model, pre-existing weights, and leverage from those in our when you are building our custom models. Okay, so we are going to start looking at a data set that is located in the Kaggle. So basically, we're going to be using this data set. So it will be faces, people's face, and we are going to be downloading this from Kaggle. In order to be able to run our notebook, you need to provide a API token, and to get that you're going to go to your first you need to create a Kaggle account and then generate an API token. So for that you go to your profile account, and then you're gonna go scroll down here and create your new API token. When you create this, when you click on this button, you'll be downloading one API token JSON, where you can just go on this cell here and run it and just choose your token. So it would be something like that. I'm not going to run it here just because this will be appearing my token on the screen, and I don't want to share those my own token. That's a private, so I should keep that safe. And so once you did the upload the Kaggle token, you are able to run this script to be downloading the dataset and unzip it. So then it would be like this. I'm gonna see something like this, and we then read the images from this UTK face, which is this guy here, and you're gonna read all the image that inside it. Then you're gonna look at some examples, and you can see here the whole path for some images. And then this is a bit different from the other data set, that it's which contain the label as one folder inside the main folder. The labels would be part of the image name. So on this case here, we are getting, so it will be showing the age, and then the gender, and the race of the given person. We're gonna see a little bit of this a little bit down. So for example, then you do some manipulation on the data, and then we extract each let's say label for our image. And as we are talking about multitask model, we'll be seeing if the image it is female or male, and you're going to see the race, but you could also check the age as well. We're going to be skipping the age. You're going to be using only gender and races, just because to make it easier for you guys to follow. And so yeah, we split those here from the image names. Okay, and then we'll do some treatment here, because we have some IDs instead of strings. So when it's 0 would be a male, 1 will be female, and the same would be here for the races. So 0 it's white, and so on. We're gonna be seeing how many images you have for each gender. So female, for example, we have this amount of image, and white and black, you see this. And you are gonna be plotting here to make it easier to look at the data. You can see that the majority of the age it's between 20 and 40, and gender it's almost the same, but male has more example of male image. Race, the main data set, it's white. And you can see here one example. So for example, this girl have 21 years old, it's a female, and the race it's white, not really white, but that's how the image was labeled. And then we see some more other example. Now we're going to show a grid of picture, and you can see here some more example, and then we are going to build our training model function. This is exactly as we have seen, so it has very little change. The main change here, it is only the function loss and the occurrence function that we are passing to our train function. So we have seen that as a train, you have seen as a fit name, so just using train model here to be more descriptive, and it's exactly the same we have seen already. And we are gonna start to build some function for our single mode task first, because we're gonna build first a model to identify only one to execute only one task. It's to basically to see if the person it is female or male, or you can also do a model to check if the person it is which race the person is part of. And here a very simple function of the how to calculate the task occurrence. This is we have seen is the same we saw before. The only difference now, because we separate into function, then you can use the same train for single task model and the multitask model. Okay. This function to visualize the results. So again, nothing to be learned here, just read the function it yourself. You're gonna be able to grasp everything. And use your function to show an image as well. And then we have here loading the data, but now you can see that we have a single task dataset. That's a custom dataset class, which we mentioned that we'll be looking later, and that's the time we're going to be looking at that. So you don't need to use the, so if you, let's go back and see what we had before. I think was on this, yeah, so how you had our data set in the previous lessons was you just got a image folder that is from Torch Vision dataset, and we had the image labeled by folder. So all the image that was inside the folder would be the same, would be part of that label name. And this class would be smart enough to look at each image and use as each folder use as a label for the image that's inside it. But in this case, now you can see everything there is not separated by folder. Instead, it is separated, it is labeled using the name of the image. So we need to handle that, and in order to do that, we need to create a custom dataset class, and that's how we do that. So basically, we are passing here what is the image path and the label for the image, and you have passed here some transformation as well, and the classes that we'll be using. So this will be used basically because we need to transform the IDs. When you are training, we'll be using the ID class, but when you are displaying, you wanted to see the class name itself, right? So we do this kind of this small transformation here, generating IDs from our class and keeping class to index, and you can use that back and forward to get the data that you want, the format that you need. And we need to also implement len function and the get item function, or let's say method, right? And so we need to read our image and in our from our path, the image path, because I need to give the image itself in our multidimensional array, if you remember on the previous lessons. And so you have to read it, open, you have to transform in tensors, and then apply some transformation to those images, and you also do normalize Normalize, we're going to be talking in the future, but to be very simple and quick in the explanation, distance normalization, it's basically to try to normalize the image. And when you are doing this normalizing, what you want is you don't want a big discrepancy between pixels in the image. For example, if one pixel is 255 red, let's say, and the other pixel is 0, it's a big discrepancy, and that can influence it in the result. And what we do is just normalize those two pixels that I gave you an example, and those will be more closer related, and that's how we do that. Okay, you're gonna go on those later in the course. And so basically that, so you in this get item have to return an image and the label for it, right? And then have to be in a tensor, and here we just build one function to help us to display the image with the label easily. That's not really required, but so basically that's how we build your custom data set, and you can read your data for whatever you want. Okay, then you are building a single task model, which will be trying to figure out what category the image falls into. So, and you'll be kind of building one model that will be able to read gender or race. So for example here, so we have a data set, right? And we can choose to read the gender or the race, and based the target that we are setting here, you can see which classes we are trying to identify. For example, here if I change to race, you can see that now the classes will be Asian, Black, Indian, others, or white, and that will be the classes that you're trying to kind of classify our image into. But I run already this notebook previously with gender, just for the sake of speed, and because the training takes some time, and we don't need to be waiting for the whole thing to run. So I run it already. So I run with gender, but if you want to test with race, it's just uncomment this, and you'll be able to classify if the image is which race the image falls into, instead of just to add the gender. Another thing, some cleanup. There was some data that was wrong. Let's say classes, and just a clean up quickly. We are going to use, if you look at our model, actually I forgot to mention here, on a single model, here we are leveraging from another model, and this model is a model from the community that was trained against the ImageNet image dataset, and this model is able to classify if an image is part of any of this category, right? If it is a shark, if it is a tiger, cock, and so on. So this is basically a data set with loads of category, and this model that we are going to use to build our model will be based on this model that was previously say trained and like shared by the community, and you're going to be leveraging from that model. Then this way is going to speed up our training model. So that's how this is called transfer learning. And basically what we're doing here, we're just grabbing all the weights that was generated by this model during the training. If you remember, we did this basically the same on our previous exercise, where you save our model, right? And you were able to load it later. So basically we can leverage from another training model and just build another layer on top of this model, for example, and that's what we're doing here. and this is called transfer learning. So let's look at it closer. We get this ResNet model, and we are seeing so this ResNet model has defined its architecture, and you can look at how it is the architecture here, down here, and you can see that it has loads of layers, layers, but all the layers, it's treating the convolution part that we already saw it. And in the very end, you can see that they have one FC, which stands for how to say, not convolutional, but a linear layer. And we can see that it's end up with 1000 neurons, and the input was 512, and you're gonna replace this layer with what we want for our own problem. So let's see how it was done here. So first we need to see what was the input for that layer before, and we keep it here, and then we overwrite what we had with our layer, and we keep this with what we had, but instead of 1000 category that we had before, now it's gonna be 512, and we're gonna create another layer now against our own FC layer, which will get the output of this into that, and output with our categories. And our category can be 2 if you are talking about gender, or 4 if you are talking about race, right? So we left that as a parameter, and this would be dynamically setting the output size for our problem, okay? And then the forward would be just first calling the ResNet model, and the output of ResNet model would be in input for our local layer, okay? And you can see just this one here. So the output ResNet model would be our input for our layer, and consequently the output for our model as well. I hope this makes sense. So please have a look on this small code here, and I believe you're gonna be understanding that pretty quick. And so this is transfer learning basically. So then another thing that we do is just set false to our gradient, to our model that we are leveraging from, just to know the risk to heat train it again. So this, when we are training, this would be skipping or the model that was already trained. And so let's continue. So here, as I already said, we are going to be choosing the target to be a gender, but it could be race as well. Then this is the model that we are leveraging, and you are going to be passing as a parameter to our model here. So now we are building our model, right? And we are passing the ResNet model that the community shared, and you can use in our problem. And here the classes amount, which will be our output neuron size, and you just put it on the CPU as we always did. Then everything is the same. So here you can see that we are passing our loss function as a cross entropy, as we always did, but was inside the function, but now we are passing as a parameter, because when you are building our multimodal, it will be passed on a custom loss function. And the same for the occurrence. So in order to calculate the occurrence, is a bit different for when it's one model and when it's multimodal. So we run this very quick on 5 epochs. So that should be more, but just to be quicker, I just put 5, but you guys can change this and see that the accuracy will be improving as we add more epochs. However, it will take longer to train. And we end up here with 72% occurrence, so it's not too bad, but not so good as well. and here you can see the result. As there we already know, plotting as the loss goes down and the occurrence goes up. Working prop, that was the data set that we used, so you can see that we were looking at the gender here, and here I'm visualizing our model in action, and you can see that it predicted this looks a man, so it's a man, girl, female, man. Here not really correct, so it's look like a female, but it's saying it's male. And here a girl, it's a female, so looks correct. So it's more or less the percentage that you saw as 76. And yeah, if you train with more epochs, that probably will increase. But I think as a quick example here, as a single model, and that's we're gonna see everywhere in the internet. So that's not any, let's say, unique, but what we're gonna start talking now, it's pretty unique, which is multitask model, and where we are gonna try to predict if the image it is female or male, and which race it is classified. So let's start with our multitask data set custom again. So because again, it's a pretty different data set where we're going to be looking at two, let's say, classification, but we leverage from the single one. So basically pass two single task data set into our data set, and then we read. So gender, we set on the gender, and race on the race. And one thing that a bit we change here, that we are trying to follow a kind of standard. So when you're talking about deep learning, usually you pass the input as X and the label as Y. So this path here is the path for our images, but then you're gonna leave it as the X, and then you keep the classes just because you can use for get from the index to the name. So we already did on the previously, so you just keep it here on this data set as well. And UI to gender, and UI race. So and we implement the get item method with basically responding the image that we get from gender dataset. We could just use race dataset as well. We just wanna handle the image, so our X here, and then we get our classes for that image. In this case, it will be gender and the race. So you can see here that you can respond in a list, tensor list with different category that this image is part of. I'm gonna leave for you guys as one homework to try to add more categories here. Then you can predict. In our case, you could use age as well, as it is available in the dataset. But for this exercise, you just keep that simple. But you could respond here the age as well. So we use the show function that you discussed already, and we load our data set. And our data set basically it is multitask data set that contain different data sets. In our case, we load gender, only gender data, and race data only. Let's say we pass some transformation as well for our image, just to kind of give more variety of image. And these transformations, it is, you can see it down here, that is basically do some crop, do some flip, rotate on the images, and then we do as so. You just follow what we already saw, that put in the data load, and we pass this to our training function. Here, just look at the classes that we had. Classes gender, it's female and male, and the race, different classes. and we look at one example. And then here we are gonna, that's the interesting part, that is basically the main part of it. Remember that we were speaking that when you are building our deep learning model, we have two main steps, which it is basically first define our architecture, and the second one is define our function laws, which will be helping the model to identify if it is learning or not. And in our case here, before we were using simple cross entropy function to calculate the loss, but however now, because it's two category, we need to look at each prediction individually and be able to return something that our model can identify as improve, or as indicator, or if our model is improving or not. So how we did this, we first identify that it's coming two classes, right? And basically this would be the output from our model here. You can see that's our label, right? And this label, it is basically what you get here, the 0 and the 1 label, and the target gender and the target race. And the output is the same, so it would be two predicted output, and where can we look at this predicted? Let me think. This data would come from multitask model, this part here we are returning. So this comes here, and the label or target or y, it is coming from this what you are returning here. Okay, so we then use two cross entropy for each of the let's say the prediction, and in the end we do we sum both prediction, and we apply some weights here. For example, gender, I applied a smaller weight, while the race would have more weight, just because it's more let's say how can I say, options, right, to be classified. So we have a bigger weights, and this you need to kind of play with this to see how this will work better, which variation work better. There is no other way rather than run it and see the results and see how the model is performing. So on a quick test here, I could see that it's more or less working properly and having a decent result. But you would have to play more with this if you want to in a real world model that you need to get the highest accuracy. And then we'll look at the model. The model is basically what we had before. We are leveraging from ResNet model, and we are replacing the fully connected. So this stands for fully connected layer, and we just replace the existing one with our custom for our problem, and then we add two more layers, one to let's say as output for our race, and another one as output for gender. And you can see that we have 5 options of category or classes for race and 2 for gender. And then we just use both here. We use ResNet 34 model, and the result of it we pass to our layer, and then you get one result to each let's say task, and you respond it. And then we try to calculate the occurrence. This function here is just to calculate the occurrence, and again we are just summing up the two results, and I'm divided by 2 here just because it's 2 classes. If it was more classes, I would divide by the amount of classes or the tasks that we have to our model. And here I'm just mentioning that if you are, let's say, when you're in debugging mode, you should replace the GPU and use CPU, because the error logs is more descriptive. It's very hard to debug issues when you are running with GPU, so you should change to CPU if you face any issue. But if first run, just leave it as it is, and just if you wanted to improve this model and have to debug, I would suggest you to change to CPU while you are still debugging. Here is the same, so we have our ResNet and again, and pass it to our model and set it to the GPU, and we pass the optimizer as you already saw. And this it's something new that you have added, that it's SDK learning rate. Is basically that the learning rate would be increasing every 7 epochs. So we start with 0.001, and then by as it goes interacting, it will be kind of let's say increasing the learning rate, and you can move faster. But it's again, you don't have to change anything here. This is the example that Pytorch gives. I'm just the same they are suggesting there. And the difference is again, so we have to pass our multitask loss calculation, not a simple, you cannot use a simple cross entropy anymore, and you have to do some extra handling, and the occurrence is the same, and everything else should be just the same. And you run here two epochs, and you can see how the model have behaving. So let's say the accuracy is improving, and the loss is decreasing, so that means it's behaving as expected, and our model is able to learn, and then we just try to use it, and as you can see, it works pretty fine. Let's see if this is not very good. It's old. Yeah, so the result of our model, it is pretty okay. So it's a man and white, man and white, man and white, female and black, female and Indian. So I would say this female is not really accurate, but male and white, this is super not good. But if we increase the number of epoch, it should get better. Let's try it. Actually, I'm gonna run it and stop the video, and let's see when it finish how it looks like. Yeah, so back, I improved I increased actually the number of epochs, and our model is behaving a little bit better, but it's not ideal yet. You can see here for here I think looks female, but yeah, I cannot say, so I can forgive the model to say that it's a man and in white, it's correct. It's a man and black, it's correct as well. It's a man and white. It's a female and white. This one here, this boy looks like a male, yeah, but it's white, it's right. So this the gender that might be wrong, and this boy, it says man, it's correct, but say it's Asian. Look at the eyes, I'm not sure if Asian, but yeah, our model it's able to predict with a certain accuracy what each image falls on. So I think if we improve our if we increase the number of epochs, that can behave better. So please try to change it yourself, and you're gonna see how it performs. So just playing here, but it's gonna take a long time. So yeah, check yourself, and later we're gonna see other techniques to improve that as well. See you next lecture.